is line 22, 7b97z51, Sinc Functions, Nyquist frequency, Aliasing signals, band limited, 5G Wow Seti. There's the alien radio signal, and this is the keyword research Wow data line 22, Sinc, Nyquist, Aliasing signals and atoms. It's where I basically look up the meanings of the words that I found in the formulas to find out what they mean and to further explain them to those of us that don't know what they are. So September 13, 2013 was when I was doing this, and today's October 6th. So the previous video was line 22, 7b97z50, quantum atomic dance, superfluid velocity, UFO transport, 5G Wow Seti. And the keyword is the Sinc function and plus reconstruction filter. Quotes and diagrams are from a blog. I think it's the same blog. Okay. Sorry. I'm just losing my breath here. It's a low pressure system today. I woke up with thunder and lightning. I got up at 7 o'clock and it was thundering and lightning. I thought, oh, here we go. Every time I try to get up early, Mother Nature has different plans. So I got up at 4 o'clock yesterday to try to do it. I had the same problem. I still got to it though. So in a mixed signal system, analog and digital, a reconstruction filter or anti-imaging filter is used to construct a smooth analog signal from a digital input, as in the case of a digital to analog converter, DAC, or other sampled data output device. So you can take a look at this diagram here. So this is figure 4.1, the Sinc function, which is the ideal reconstruction filter on the left, and on its frequency response, the box function on the right. So this would be, the top one would be the left, and this one would be the right. Okay. So this is a reconstruction filter. Now to me that looks like a Higgs signal. Okay, just the way it pops up there like that. So a band limited and properly sampled function can be perfectly reconstructed by convolving the set of samples with the Sinc function. This is the second part of the sampling theorem, which can now be given its complete form. Theorem 5, sampling theorem complete. A function fx that is band limited and sampled above the Nyquist frequency is completely determined by its samples and can be perfectly reconstructed by convolving the set of samples with the Sinc function. Spectrum of data distribution, replicas due to sampling, spectrum reconstructed with ideal reconstruction filter, spectrum of ideal reconstruction filter, alias frequencies. It's quite the graph there, eh, with all the little lines on it and stuff. Okay, so it's showing the different frequencies and stuff. So figure 4.2. When a function is sampled below its Nyquist frequency, the original frequency response will overlap with nearby replicas of itself. So it's like creating a dual signal then. Even if the ideal reconstruction filter is used, an alias spectrum is reconstructed. So I don't know if that means two signals or not. However, there are a few problems which arise in practice. The first problem arises when the function is not band limited or it is sampled below the Nyquist frequency. Then it happens that the replicas overlap with the original spectrum of our function, and when we multiply in frequency domain with the box functions, we get an alias modified spectrum. That is a spectrum which has aliases of higher frequencies. Therefore, this phenomenon is called aliasing. So it says something about getting a higher frequency. Figure 4.2 depicts this concept graphically. The real bad thing about this is that this problem depends only on the sampling rate and whether the function is band limited or not. There's no way to reconstruct an improperly sampled function. What happens when a filter different from the ideal filters used for reconstruction will be discussed in the next section. So on the blog post is www.cg.tuwien.ac.at. Under sampling, when the sampling rate is lower than or equal to the Nyquist rate, a condition to find is under sampling. It is impossible to rebuild the original signal according to the sampling theorem. An example is illustrated below, where the reconstructed signal built from data sampled at the Nyquist rate is way off from the original signal. So this diagram shows under sampling, time, magnitude, and original signal, and it's a standard sampled point and then reconstructed signal. And that's from www.efunda.com. There's a link there. Aliasing. Undersampling causes frequency components that are higher than half of the sampling frequency to overlap with the lower frequency component. As a result, the higher frequency components roll into the reconstructed signal and cause distortion of the signal. Oh, that's your problem. It distorts it. Okay. This type of signal distortion is called aliasing. Now it explains itself. The schematic below repeats the above aliasing argument in the frequency domain. So the original signal in frequency domain, and then we have periodic duplication in frequency domain, aliasing. This is the magnitude. This is undersampling, leave out higher frequencies that will contaminate lower frequencies, so you have to separate your signals. Negative frequencies will show up after Fourier transform, although no physical meaning. Effective sampling range, Nyquist frequency, sampling rate 2, and then frequency. Frequency information based on the sample signal that will be used to reconstruct the signal. And all these signals remind me of the Higgs boson signal, how they jump up that high. The same kind of like mountain look. Mountain peaks. So, spectrum of sampled signals sampled at less than the Nyquist rate. And again, from the blog www.efunda.com. Okay, it's a little more than that, but you can see the link there, and it'll be on the video. So, September 14th, keyword Sinc Function will continue in the next video. Thanks for watching.